Good evening, friends. Okay, now I asked you a question yesterday in the previous video. What was the question asked? If in the same problem, if I have two masses and these are being pulled by two different forces. If you remember my previous video, this was the video that I had. Okay, this one. Okay, wherein you had the same force. Okay, let me go to this one. Okay, you had the same force. F and F were being applied over here. And I had asked you if the same force is applied, what will happen? Okay, and I had solved the solution, gave the solution for this also. So just a minute. Okay, so I had said that if the same forces are applied, then what is the distance moved by both of them? Then I showed you an example. How do we do this? Okay, now the question I had posed at the time was that if the forces are not the same, then definitely this is F2 and this is F1. Now what will happen? Now how do we do it? Now the response that I got from you guys, one of you had replied, she said that the F2 is applied like this, F1 is applied like this. I applied F2 minus of minus F1, right? Net force should be equal to K times X. So I had asked here not the distance moved by every block. I had just asked what is the maximum elongation? Okay. So maximum elongation should now be equal to X equal to F1 plus F2 divided by K. Now, what is wrong in this? This is a misconception once again. Okay, what is wrong is that, see, these two are two different forces. F1 and F2 are different forces. Let us say, for example, if this is 10 Newton and this is 6 Newton over here. Now, what can happen? So, this force is larger than this. Don't you expect that apart from expansion, this will also start moving like this? The entire system will now start moving at the same acceleration. Will that not happen? Now, you may ask me a question. If this is the case, why didn't we apply it in the previous problem? See, here also a similar thing can happen here, right? But why didn't we apply here? The reason why I did not apply here is that this force and this force are one and the same. So you cannot expect that these two objects will be moving in the same direction. This will be moving like this will be moving like this. Okay. So if the forces are different, then there is a possibility that both the masses will move in one direction, whichever force is larger as compared to the smaller one, right? So now towards it, now we have a concept name known as, okay, so this will have a larger force, let us say, and this will have a smaller force. And as a result of it, the mass M2 can move in this direction. Let us say that both the masses will now get accelerated with the same acceleration E. Okay. So therefore, now you cannot apply this method. When I apply this method, which means that, okay, these two masses, one mass is moving like this, other mass is moving like this, okay, and they're not moving together. That's what it tells you. Okay, so which is incorrect because when you have unbalanced forces, the mass, the setup, the entire system will move in the direction of the larger force. This is a misconception you have missed. See how basic differences you can see. Okay, now let us start solving the problem. Now towards it. Now if they are moving in the same acceleration, now what I'll do is, I will say, let us take up the free body diagram for each object. For the first object, that is M2, this is the spring, this is the mass. What is this mass? M2 here. And this is the force F here. Now, when you apply a force F2 over here, this is now pulling it backwards with a spring force Kx, right? Okay. And as a result of it, now I can now write F2 minus Kx is equal to M2 into E. Okay. So direction of this force is positive, direction of this force is negative because it's in the opposite direction. Let us take up the other block. The second block, M1. Now, what is the force acting here? Why should the block go like this? Because there's a Kx force, okay, which is, though there is a force F1 acting here, there's a force F1 acting here, but there's also a force which is dragging it like this because of this force. And what is this? This is your spring force Kx. Now, applying this, now what is the direction of the acceleration? In this direction. So I can still write Kx is equal to Kx minus F1 is equal to M1 into E. Why minus F1? Because I will consider this as the positive direction and the object is still moving in this direction. So Kx minus F1, Kx is positive direction force, this is negative direction force. This should be equal to net force, which is M1 into E. Now what do I need? I need the value of X here. And in between, you see, you have two equations. F1 and F2 are known. X is what it needs to determine. K is known. But this A is a culprit here. Okay, I somehow need to eliminate that. So, simple concept, simultaneous equations. So what I will do is, I'll multiply this by M1 and I'll multiply this by M2 and subtract one from the other. Which means what? I'll do M1 F2 minus M1 Kx is equal to M1 M2 into A. And then here similarly, I'll write this as M2 Kx minus M2 M2 F1 is equal to M1 M2 into A. Now, let us subtract. Let me call this equation number 1. This is equation number 2. Or maybe I can directly solve this. These two cancels. So therefore, now this becomes M1 F2 minus M1 Kx minus M2 Kx plus M2 F1. What I have done is nothing but I have just subtracted 1 minus 2. That's what I have done. Okay. So towards it, let me put all these x quantities on the other side. Hey, is the x missing here, right? M2 F1 into x. See, you have to be very, very careful. Okay. So now I'll write this as M1 F2 plus M2 F1 is equal to M1 plus, is there a K2 here? No, no K2 here. Okay. No K2 here. M1 plus M2 into K into X. In other words, I need the value of X. So I eliminated the value of A here. So I get the value of X to be equal to M1 F2 plus M2 F1 divided by M1 plus M2. What is this now? This is your net, and I missed something here, divided by K. Okay, so this is your net expansion of the string. One thing that you need to note, see, when I wrote this expression, okay, I immediately realized, hey, how come this is X? I missed the value of K. How did I realize? Whenever you are arriving at a complete solution, one solution, first thing is you do not know whether this is right or wrong. Okay, you think that this could be right. But see, if you look at the units here, this is kg into Newton, and here it is kg, which means what will happen? Kg Newton divided by kg will become Newton. But here on the left hand side, this is meters. So this is not correct. So if you want meters, then what I should do? I should have something else here, right? Okay, what is this K? K is nothing but Newton per meter. See, this Newton goes away, meter comes upwards, and thus you get meter on both sides. Okay, so thus we have verified LHS equal to RHS from the concept of dimensions also, units and dimensions. Okay, so all this which you study in individual chapters, okay, really matters for you. So you should be careful while solving these problems. Have a look at it and get to know how to employ or how to use this. Okay, this will help you out in future also. Thank you, friends, for watching this video until the end. Like this video, do share amongst your friends, comment if you have any other questions, and subscribe to my channel for more updates. Thank you, and thank you once again.